What's up, math scholars? It's a sunny February day, but everyone's looking really tired today, so hopefully you can cheer up and get excited about learning 5.5 day 2. So we're going to be finding common denominators, and that's going to allow us to add and subtract these fractions. You guys getting excited? Yeah! Woo! They're barely smiling right now. They're so tired. Take a nap after school, everybody, unless you have work. Okay. Here is going to be your strategies for adding and subtracting fractions if they have unlike denominators. You'll be on your own to find that like denominator, that common denominator. So step 1 will be find the least common multiple of both your denominators. So do what you did yesterday. You might need to do some factoring before you compile your least common multiple list. Your least common multiple is your common denominator. So you will make both your denominators the least common multiple and multiply accordingly to adjust your numerators. So I'll click pause and allow the class to write all this down. All right, so here's our first sample problem. We're starting simple for you guys. Obviously, we're trying to subtract here, and we do not have common denominators like yesterday. So we have a little bit of work to do. We're going to really focus in on our two denominators. We have 4x as our one denominator and a 7 as our other denominator. So we'll do what we did yesterday. We'll compile a least common multiple list. So I would do what I did yesterday with the 4, and I would write it as 2 squared times x. There's really nothing to do to the 7, so that's going to make our life easier. Let's compile our least common multiple list. So if I check mark my 2 squared, there's no 2 here. What would go on my list? Okay, so I put my 2 squared on my list. I'm going to go ahead and check mark my 7. There's no 7 up here, but 7 does need to go on my list. And then I'll check mark my x and I'll put it on my list. So I am going to go ahead and multiply these numbers together to see what I get. 2 squared is 4 times 7 is 28. So 28x is my common denominator that we will be using. Okay? Makes sense? All right, so let's do it. We're going to make both denominators a 28x. So I start by just putting a 28x and making that both my denominators. Now we have to use multiplication and adjust our numerators accordingly. So here's how that works. Just like it worked in 3rd grade. I think to myself, what would I multiply 4x by to turn it into a 28x? And that's a 7. But you can't just do a 7 on the bottom. You have to do a 7 on the top as well. And that gives you, the reason you do 7 over 7 is 7 over 7 equals 1. And so multiplying by 1 won't change the overall value of the original math problem. So 7 times 4x is 28x. 7 times 3 is 21. That's my new numerator. Nod if that makes sense. All right, let's do our second fraction. What will I multiply the 7 by to turn him into a 28x? A 4x. And you have to do that on the top and the bottom as well. So 7 times 4x is 28x. 1 times 4x is 4x. So any questions? That's the hard new part. Everything from here on out you did yesterday. So we're ready to rock and roll. We have our common denominators. We're going to go ahead and subtract the top, 21 minus 4x, and we're going to keep the bottom at 28x. And that's all you can do. There's really nothing I can factor or cancel in this one. You absolutely would not want to slash these x's out. That would be like illegal math move. So you're just going to leave it right here. How fun was that? Smiles all around. All right, let's try a little bit harder of one. Okay, jot that down, and we're going to use factoring and find our least common multiple list. I have LCM/LCD, least common denominator, because they're the same thing. There's my first denominator. It's already factored. That's awesome. Here's my second denominator. Looks like it needs to be factored a bit before we make our list. So how can I factor down 9x squared minus 12x? Pull out a 3 and an x, leaving us with a 3x minus 4. All right, now this is going to sound crazy, but I'm actually going to cover this up and put the 3x times 3x minus 4 in its place. So rewriting this so it's in factor form will make your life easier in a couple minutes. What? So I'm writing that second denominator in factor form. All right, let's make our list. I've got a 3 on my list. I've got a 3 on my list. I'll put a 3 as part of my least common multiple. I've got an x squared on my list, and I have an x on my list. What would I put down here? X squared. And then the very last thing is this group factor. So as a group, I would include 3x minus 4. So that's our common denominator that we'll be using. So any questions making our list? That's what we did yesterday. All right. So I'm going to give myself some space. Even move this up a little bit. Some room. So all my denominators will now be 3x squared times 3x minus 4. 3x squared times 3x minus 4. You can see these problems start getting a little bit bigger and a little more complex, and that's what makes this stuff a little difficult. All right, how are we going to turn a 3x squared into a 3x squared times 3x minus 4? I think to myself, what do I need to add to it? So, yeah, I need to add a 3x minus 4 to this first fraction. And you'll do it on the top and bottom. That's supposed to be a 3x minus 4. My smartboard is just not behaving itself up there. Okay. Now see that 1? If that had been a number other than 1, it would need to distribute in. But since it's just a 1, it's going to become a 3x minus 4 up here, okay? Okay. Ready to do our second fraction. If I'm starting with a 3x times 3x minus 4, and I want to become a 3x squared times 3x minus 4, what do I need to add to this guy? Just a single x, right? So what you put on the bottom, you have to put on the top as well. And then my top will be x times x, which is x squared. Phew, that was fun. It's a lot. I know it's a lot, and I'm sorry about that. We're ready to go, though. We have our common denominators. We're ready to add, and then I don't think this one simplifies any, so we'll be done quickly. I need to give myself some space. Let me scroll it and move this down a little bit. So our final answer is what? Okay, let me hit this button you can see. So the question was, how do we get the x squared? We had looked at our original denominator here, and we looked at our new denominator here, and we saw it was short, a single x, okay? So we added an x here, and you have to do on the top the same thing you do on the bottom, and these two give you the x squared. Okay, so I'm going to add my numerators. X squared plus 3x minus 4. And then my denominator would be the same thing as it was above. 3x squared times 3x minus 4. Now you can attempt to do old-fashioned factoring method on the top. It would factor down to x plus 4 times x minus 1, but that's not going to allow us to cancel anything. So I would just leave it how we have it now. All right, we're going to do one more of these common denominator problems and then do one complex fraction problem, and then we'll be done. So let's look at our two denominators. We've got a 9x squared as our first denominator and a 3x squared plus 3x as our second denominator. So both of these can be rewritten slightly. What do you think I'll do for that first denominator, the 9x squared? Good, make it a 3 squared times x squared. So we want to write our numbers as products of prime numbers. Okay, what can we do with our second denominator as far as factoring is concerned? There is a common monomial, a 3x. And that will leave me with an x plus 1. So I think I'm ready to make my checkmark list. Oh, real quick, I'm going to do what I did in that last slide and rewrite the second fraction in factored form. So I'm going to rewrite that part right there in its factored form. So this would now be 3x times x plus 1. That'll just make life easier when we're changing our denominators. Okay, check mark list. If I've got a 3 squared and I've got a 3, what will go in my least common denominator list? Good. Use the highest power that you see in your factors. If I've got an x squared on my list and I have an x on my list, what will go down here? X squared. And there's only one other thing that hasn't been checked off. It's this group factor of x plus 1. And we just found the common denominator we'll be using. Yeah?
Could you change the x squared to 3 squared plus 4 times x squared?
Like here? Nah. I'm actually going to turn this into a 9. So Lexi's question was, should I change this 9 up here to 3 squared? I think our easiest bet would just be to change this one to 9. We can be thinking in terms of 9s. All right, so I've got my common denominator. I'll go ahead and write my common denominator for both of my fractions. It's a 9x squared times x plus 1. 9x squared times x plus 1. All right, let's look at our first fraction. I used to have a 9x squared, but now I need a 9x squared times x plus 1. So hopefully you agree we need to add an x plus 1 to the situation. I'm doing the top and bottom. Now this one is like I was talking about in the last one. See that 7? It is going to have to distribute it into everybody. So I would make it a 7x plus 7. All right, we have to look at this really close. So we currently have a 3x times x plus 1. We want to have a 9x squared times x plus 1. So what are we thinking? A 3 and an x is what we need to kind of add to it. So I can do that on the top and the bottom. And that 3x and that 3x then together can make that 9x squared. So my new numerator is 3x squared. Okay, I'm going to give myself a little bit of space and write our final answer. Down. Okay, so I'm going to add my numerator together. I'll write the 3x squared first, just so it's in standard form. And then the bottom, 9x squared times x plus 1. And I would leave it like that. I think you could probably use the box method to try to factor that top part, but I don't think it's going to give us a factor of x plus 1. In fact, I don't think it's going to be factorable, so it's fine. You survived the hardest part of the lesson. How did that feel? Are you feeling overwhelmed? I hope you're not feeling overwhelmed. I hope you're like up for the challenge. Okay. We have one last topic to touch on, and that's the topic of complex fractions. How are we on notes? We good? You don't need to pause it? Okay. So the last topic, you don't need to write this part of it down, is complex fractions. It simply states that a complex fraction is a fraction that contains a fraction. So it's like a picture in a picture television. It's fraction within a fraction. I'll show you what one looks like. Ta-da! So I know it looks really hard, but it's actually really easy to deal with. We're going to use a fraction clearing technique. Have you ever heard of fraction clearing technique? We used to teach it in Algebra 1, but I don't think the new book has it. Basically what you do is you look at all your denominators. You find a common denominator for all of the denominators, and you multiply through by that number. It'll clear the fractions, like magic. So let's look at all of our denominators. We have a 6. We have a 3. We have a 5. We have a 10. What's a good common denominator for all 4 of those numbers? 30. Good. Thank you, scholarly people. So we're going to take that 30, and every single fraction is going to multiply by 30, okay? So we're going to do a times 30 here, times 30 for the second fraction, times 30 for this third fraction, times 30 for this fourth fraction. You basically you do your multiplication to every single term. All right, so what is 30 divided by 6? Because that's, in a sense, what happens here. 5. So this term in the upper left will become 5x. The fraction has been cleared. Yeah. How does it work? It just becomes 30x over 6. 30x over 6 is 30 divided by 6. 5. Okay. So I kind of look at it as a slash. So I kind of think 30 divided by 6 equals 5, and I kind of slash it in my head. So in this one, I think to myself, with 30 divided by 3, I slash it. I think, oh, it's 10, and then I do 10 times x. You can think about it however you want to think about it. Is that better? Okay, so 30 and 5, I slash. What's 30 divided by 5? so that'll be a 6x. And then 30 divided by 10, I slash. What's that become? 3, and what's 7 times 3? 21.
Wait, did you say multiply the numerator by 30?
You're multiplying every single term, every single fraction, all 4 of them, by 30.
So...
With the goal being that the fractions are cleared. Yeah. Okay, so now that all 4 of our fractions has been cleared by multiplying by that common denominator, I'm ready to rock and roll and finish the problem. 5x and negative 10x are like terms. I would make it a negative 5x. And then 6x and negative 21 are not like terms. And you'd want to stop right here. You cannot slash or x out. That's illegal. So you're pretty much done. Okay? All right, I'm going to go to the slide with the homework so people watching the video can see that slide. Are we done writing stuff down from this one? Wait a sec. Just tell you when. Paused it. And there's the homework. It's in the book. Make sure you're showing all your work.